Welcome to the abstract for this series of videos. This is presented as 3 slides which provide a whistle-stop 10-minute rundown of all the main points, followed by a checklist of findings. The 10-minute summary is covered in 3 slides with a lot of text, covering a lot of topics in a rapid-fire blast. The checklist is covered in a single slide, explaining points and achievements which have been established pretty robustly, topics where at least the principles are established, but the details remain to be worked out, topics that remain to be explored, and examples of things that are likely to remain outside the scope of covariant compactification. I'm providing this for the benefit of any viewers who have a solid understanding of modern unification physics, but are pushed for time and just want to get a sense of what's in these videos as quickly as possible. From my research, the picture of the universe that's been emerging is as follows. In deep space, where there's no matter and all gauge fields and gravity are negligible other than that related to the background geometry, the space-time reduces to a Cartesian product of 4-dimensional de Sitter space and a 6th sphere. In this situation, each spatial geodesic lies entirely in either a 3-sphere or the 6th sphere. Perturbations from this background geometry are experienced as matter, gravity, and gauge fields. At a given moment in cosmic time, the volume of space is an invariant under changes of coordinate system. In the absence of perturbations to the background geometry, this takes known values for each of the spherical factor spaces. Locally, this volume is described by the square root of the absolute value of the metric determinant. This is a coordinate-dependent field, and in the general case, it can be decomposed approximately as a linear sum of harmonics of the product space. These harmonics form multiplets of the isometry group of the product space. The smallest non-trivial multiplet transforms as a product of a 4-spinner on S3 and a 4-spinner on S6. This represents a 16-component matter multiplet above the electroweak scale, at energies at which the Higgs mechanism is not in operation to give it a mass. Massive multiplets have one more quantum number than massless ones, that of spin. For these, we have one 16-plet with spin up and one with spin down, giving us 32 components in total, precisely the right number for all the states in a single generation of fermions, if a sterile neutrino is included. If we take the outer products of a 32-spinner and its conjugate, we can use the Clifford algebra matrices to project out multiplets of higher harmonics, representing composite fields. In deep space, root mod G is an exact linear sum of harmonics. Thus we have background fermion fields and all composites of them. An active rotation of the 3-sphere can be visualized as dragging field configurations around with it. This results in a mixing of the components of each of the corresponding 4-spinners, which can be represented with an element of chiral SU2 cross SU2. I'm currently trying to clarify the relationship between these 4-spinners and Dirac 4-spinners. We can use a locally orthonormal coordinate system at any point in S3 to decompose the 4-spinner components into a Fourier series. The Fourier components are distinguished by a 3-component wave number. It should then be possible to boost this to other local inertial frames, giving us a 4-wave number. One perturbation of the background geometry is to homeomorphically deform the 3-sphere. This perturbs the harmonics. From the second derivatives of the fields, we can get their energy momentum densities. For root mod G, we find that this density is described by the Einstein tensor. Then, to get the energy and momentum carried by a field configuration, we integrate over the whole three-sphere. Any localized perturbation changes the decomposition of the fields into Fourier components. This represents modes of matter fields beyond what's present in the vacuum limit. Such localized perturbations could result in a localized spinor wave packet with spreads in wave number and space-time position related by an uncertainty principle, which appears to be that of Heisenberg. With the background geometry, root mod G for the extra dimensions is a linear sum of harmonics on S6. These form multiplets under SO7. This SO7 action on the coordinates is non-linearly realized. However, it's linear for rotations, which preserve the origin of the coordinate system. An active rotation of the sixth sphere, which preserves the origin, can be visualized as dragging field configurations around with it. This results in a mixing of the components of each of these four spinors, which can be represented with an element of SU4. This SU4 contains the SU3 gauge group relating to the color charge of the strong force. To understand what it means for this gauge symmetry to be gauged, we again look at the perturbations of the background geometry. This time by considering homeomorphic deformations of the sixth sphere, which vary with coordinates in the 4D spacetime. There is then a map from the spinors on the deformed sixth sphere at any point, at any event, the spherical harmonic on the unperturbed sixth sphere. It seems logical that, in trying to relate the harmonics at different 4D locations, there will be an ambiguity based on the choice of homeomorphisms at this point. Thus, a path through 4D spacetime becomes a Wilson line, and the choice of homeomorphisms along it becomes an SU4 gauge. This determines the variations in the fermion wave numbers in the extra dimensions. If the path is a closed loop which has a non-zero SU4 transformation along its entire length in a given gauge, a gauge transformation can eliminate the mixing of the harmonics for part of the path, but the total shift must remain in any gauge. By contracting this loop, we find that there must be a non-zero SU4 field strength within the loop. This is an SU4 version of the Aharonov-Bohm effect. The field strength is essentially given by a set of components of the Riemann curvature tensor, which quantify the warping of the compact factor space as you move around the 4D spacetime. We identify the one component of each 16 spinor which we expect not to interact with any gauge fields, the right-handed neutrino. We take this to be a background state. Exactly what this means is still being determined. It could be, for example, that root mod G for the background geometry is primarily or exclusively composed of this harmonic. This state is invariant under precisely the standard model gauge group, color SU3, weak isospin SU2, and weak hypercharge U1. If there's an intrinsic warping around a loop in 4D spacetime, this acts on the 4 spinor of S6 as an SU4 transformation. But the presence of a background field will result in this transformation being non-linearly realized. Something similar is expected with the chiral SU2 cross SU2. This seems to imply that we need to redefine multiplets to give us so-called standard fields which transform linearly under the standard model gauge groups. The perturbations of these standard fields away from these background forms would then be identified with quarks, charged leptons, and left-handed neutrinos. The quark color states will then, as expected, be related by SU3 transformations within the SU4 group. All of these fermion states have the correct quantum numbers for these quarks and leptons. We therefore have some geometric understanding of all of the standard model gauge groups. However, further research is needed to refine these ideas and give them and understand them in greater detail. To close this video, I'll briefly summarize what topics I've covered so far in this program of research and what it's achieved, and also what I've yet to explore and what I don't expect it to look at all. As I've developed this theory, it's become clear that it's implying that the curved universe we live in has 10 dimensions, and that it has a specific shape in deep space. There's also a decompactification limit in which all the curvatures are reduced to zero. Its equations imply that if the universe simply had the geometry of deep space, the Big Bang singularity would be replaced by a bounce, but I haven't yet determined whether this feature persists in a matter-filled universe. The geometric features of the universe and the quantum numbers of its harmonics are determined by careful study of its symmetries. These harmonics include spinors, and their quantum numbers are those of a generation of fermions, including 2 flavors and 3 colors of quark. There are explicit forms for the generators of the Lorentz group and the strong and electroweak gauge groups. The Aharonov-Bohm effect and Wilson loops for gauge symmetries arise naturally within this framework. I demonstrate this explicitly for an SU4 gauge group, which contains that of the strong force, and explain its geometric meaning, subject to possible future refinement. The basic principle of how this symmetry is broken down to that of the strong force is explained, but I've yet to demonstrate this through explicit calculation. The understanding of the electroweak symmetry is very new. The geometric meaning of this symmetry and that of parity for massless fields is fairly clear, but there are various aspects of its relation to Lorentz symmetries and charge conjugation, at least for massive fields, that still need to be clarified. This is among the top priorities for my research. I provide field equations for both geodesic and non-geodesic paths in this spacetime. The 4-dimensional part of that for geodesics is a generalization of Poisson's equation for gravity. Einstein's field equation is derived and given a new interpretation. A sufficiently localized perturbation of the background geometry can be viewed as a wave packet, and it satisfies a pair of uncertainty relations which appear to be those of Heisenberg. However, I've yet to develop a detailed understanding of the dynamics of these perturbations and the breaking of the SU4 and chiral SU2 cross SU2 symmetries, which will determine whether lepton number is conserved and hence whether proton decay is possible. Beyond this, there's the question of how the Higgs field arises and couples to the massless fermion fields. This is necessary for a full understanding of the geometry of the electromagnetic field. Without this, it's unclear how fermion characteristics such as electric charge, momentum, and position can be probed. The final video will suggest some possible sources of the famous indeterminacy of quantum mechanics, but in covariant compactification, this appears to be an emergent feature, and further work needs to be done to reveal how this can arise. At present, the theory has no directly testable predictions. It contains some predictions which are not directly testable, such as the existence of a right-handed sterile neutrino and a compact space of extra dimensions with a radius of the same order as the pseudo-radius of the de Sitter space of four-dimensional spacetime. But to get testable predictions, further work will need to be done. Further research might reveal, for example, a relationship between the large-scale curvature of spacetime and the strength of the force between nucleons, or mass differences between the three fermion generations. However, I can't reasonably claim to be on the verge of such findings, and I would caution strongly against any other researchers trying to rush through back-of-the-envelope calculations in this theory, at least unless they have fully understood it, particularly by using techniques or principles from existing theories of fundamental physics. This is a very different type of theory from existing quantum field theories, and many of the familiar rules and concepts no longer hold true here. For example, for at least some of the broken or non-linearly realized symmetries, breaking doesn't occur as an energy scale is changed, and there are no corresponding Higgs fields or Goldstone modes. Finally, it's worth remarking on subjects which the theory is unlikely to say anything about directly, even after further research. Covariant compactification seeks to describe the fundamental constituents of the universe that we live in. It does not directly say anything about the structures built out of these constituents, such as atoms, molecules, gases or solids or other states of matter, or living organisms. Within the theory, there is an aim to show how quantum mechanics can emerge from the underlying geometry, rather than being postulated at the start. Now, some researchers are of the view that quantum effects cannot occur without consciousness. This is not a view I share. Indeed, I regard the term consciousness as ill-defined and falsely assumed to have a binary existence, that is, it's either present or it's not, because of a human-centric mode of thinking. Instead, even if it is possible to define consciousness in a rigorous way, I expect it to be an emergent phenomenon relating to larger scale structures. The place to look for this, in my view, is the interface between neurology, psychology, and evolutionary biology. It's possible that there is still a direct link between quantum theory and the mind. There's currently some interesting research being done on this, but if so, I expect quantum phenomena to be the cause, not the effect.